Hello ladies and gentlemen, Root Beer here once again. I'm going to be looking in this video at question number 10 on the Manitoba Math Contest. We're going to be finishing up the 2018 paper. This is the last question, and hopefully you guys have given it a shot. If not, pause the video and try it out for yourself. I really encourage this. Practice makes perfect, and it's more important for you to be practicing with pencil to paper than just watching a video or reading an online solution. Okay, having said that, let's get into question number 10. What have we got? A secret society meets once per year in the middle of a circle of 101 equally spaced lanterns. In year 0, one lantern is lit. In year 1, they lit the adjacent lantern, just like what we've got down here with a picture. After each year K, proceeding clockwise, they skip 2K lanterns and change the state of the next lantern. So if it was off, they turned it on. If it was on, they turn it off. Or I guess if they light it if it's not lit, and extinguish it if it's unlit. Yeah, that's what they say down here. So in year 2, they would skip 2 lanterns. That's what they do. And then in the next year, they skip 4. After year 3, they skip 6. So it's in year 4 they skip 2 times 4 minus 1. It's an odd way to count. It's suspicious that they're starting at 0 for things. We might want to start at 0. Anyway, determine with proof, obviously, how many lanterns remain lit after they meet in 2018. So after they meet in 2018, this is going to be a little weird because the numbers I feel are not matching up between when they say what the year number and after and things like that. It seems oddly written. Okay, so 101. Now that's a big number. So a good idea might be to look at a smaller circle of lanterns with numbers whose properties are similar to 101. Now, what properties and how should they be similar? Well, it's kind of hard to say. Now, they've had questions similar to this before, I think switching lights on and off, and so we might think binary. We might want 101 to be represented in binary, and we want a similarly binary-ish number. 101's also prime. It's the 3-digit number. I can't really think of any other properties that we might want for 101. So we might look at, 5's another prime. So we might look at a smaller circle of 5. I guess that would have been 7, and that would have been okay too, but okay, we might say, well, in year 1 they light this. Well, not in year 1, in year 0. So we might want to number our lanterns as well. But let's go over to the page. That way we have more freedom. 1, 2, 3, 4, 5. Okay, so let's say 0, 1, 2, 3, 4 actually give numbers to the lanterns. That way we might be able to say, in year K, they light lantern 2K plus 6 or something like that. So in year 0, they light this lantern. Okay. Then for year 1, they skip 2 times the previous year. So they meet in year 1, and after then, 2 lanterns are lit. So I'm also trying to, in my head, use the specific language that they're using so I can get a handle on where they want the answer to come from. So if they said after they meet in year 1, and it was 5 lanterns in a circle, I would say 2. Okay. So then in year 2, they skip twice the previous year. So skip, skip, and we're at 4. Now 0, 1, and 4, these are squares, perfect squares. But is this a coincidence? Well, the next one should be, I guess, if it is squares, then it should also, the next one, I guess, I'm going to predict is, we'll go all the way back around to 4, and we'll extinguish that. But let's see. So in year 3, we do 2 times the previous year. So 2 times 2, we skip that many. So skip, 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 and look at that, and we will extinguish what was lit there. And then the next year will be year 4. So we've done year 0, 1, 2, 3. So we'll do year 4, so that's twice the previous year. So we 1, 2, 3, 4, 5, 6, and now 1 is being unlit. And in year 5, we skip 8, because it's 2 times the previous year, so we're on 1. 1, 2, 3, 4, 5, 6, 7, and we're back to lighting up the 4 again. And then in year 6, we'll skip 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 4 is unlit again. I feel like we are just going through squares, but maybe this is coincidental. Let's do another one. Also, the 0 is not being unlit here. That's curious. So for year 7, we'll skip 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll light the 1 again. Do we ever get rid of the 0? Does the first lantern stay lit the entire time? 8. So that would be 14 we skip. And we're at the 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14. Okay, so the 0 will become unlit again, eventually. But yeah, it looks like it was just squares. But maybe that's some freaky coincidence of the number 5. Okay, let's, I mean, I chose 5 because it's a small number and it's prime like 101 is prime. Because that's a property that really jumps out at me, but, you know, let's try a non-odd prime. So let's go with 9. Or sorry, a non-prime odd, I meant. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll call them 0, 1, 2, 3, 4, 5, 6, 7, 8. So, year 0, this is lit. Skip 0, lit. Skip 1, 2, lit. Skip 1, 2, 3, 4, and this becomes unlit. And now skip 1, 2, 3, 4, 5, 6, and then that'll mean that 7 becomes lit. Now 7's not a perfect square, but 7 is, or 7 plus 9 is 16. We have gone around the circle once, so yeah, it looks like we're doing primes. So that makes, I guess that sort of makes sense, because if I'm at lantern K, well, they use K in the question. If I'm at lantern, let's say N, then, and it was, well, let's actually write this up because I feel like knowing that we're at squares should be important. So, so we'll say we claim each year how best to word this? Well, actually, we can say what specifically it'll be. So we claim in year N, they meet and not light, but say change the state of the lantern with value n squared modulo 101. That is to say, the remainder when you divide by 101. And this is, of course, if the lanterns are numbered clockwise, starting with 0. Okay. So we'll probably have to prove this statement by induction, but yeah, I think it's good. So we made a claim. Let's prove it. In year 0, lantern 0, which is equal to 0 squared, is lit. So now, the induction step, assume the statement is true for year n. So when the society meets in n plus 1, in year n plus 1, I guess we should say, they skip 2n lanterns, and so change the state of, how do we say it, of the lantern. I keep writing lantern. Oh, there I wrote lantern. But there it is. I'm sure somebody at home was screaming about that. Lantern. It kept looking off to me, but I thought it was part of the ERN. I thought maybe there was a U there, but no. I keep writing lantern. Anyway, change the state of the... Incidentally, you don't get points off for not spelling properly, unless you spell really horribly and spell the word lantern like you spell the word banana or something like that. So change the state of the lantern 2n plus 1 spaces clockwise. This will be the... doing it again. That's the problem. Your hand gets used to writing something. Jeez. Lantern. Lantern, lantern, lantern. So this will be at the lantern at position n squared plus 2n plus 1. Modulo 101. You don't have to keep writing modulo. That's the way I'm most comfortable writing it. I also think it's the simplest way to write it. But you could say the lantern whose position is the remainder of n squared plus 2n plus 1 when you divide by 101. But that's just so much more writing than saying modulo. And the markers know what modulo means. Most mathematicians know what modulo means. Anyway. So this is the lantern n squared, or n plus 1 squared. Modulo 101. And by induction, our result is proven. Okay. So this is a big step. I know which lanterns are going to be lit or unlit, and each year. Like, I can predict it every single time. Now, the question is, at the end of the process, because I don't want to do 2018 years, we want to try and start figuring out a pattern of, well, okay, this lantern here, lantern 0, when are you going to be turned off and on? Because you notice I was quite worried, will 0 ever be turned off? And it was after year 8. That's when it was turned off, when I was doing the circle of 5. So we might ask, okay, now we know which lanterns will be touched and changed, but can I now say, okay, after 2018 years, lantern 2 was flicked on twice and flicked off 3 times, or something like that. So when is a lantern going to change? Well, when they arrive at it again. So when does a lantern that is on eventually turn off? Okay, and can we count that number of times? That's, I guess, our new goal. Because then if we can figure that out, then we can just go to each lantern and say, all right, lantern 3, when were you turned on, when are you turned off, and how many times does that happen throughout the course of 2018? That's at least my plan. Because I don't quite understand the system yet. But I understand squares are important. So, if lantern... So, there our claim is done. Let's draw that line a little bit better. But there our claim is done. So, and incidentally, this is all technically what you might consider sort of rough work. You know, what I would want written is that claim there. But me playing around with 5 and 9, irrelevant. And I'm back to sort of rough work now. Which might eventually blossom into something useful. But it's important to be aware of what I'm writing and what I wouldn't write, and that sort of a thing. So, if lantern K is lit, does it become unlit ever? And when? You'll notice in that first example, when we were doing 5, 4 got lit and unlit a lot, but it took forever for 0 to become unlit. And I think 1 got lit and unlit a couple times in there as well. In fact, it might be very interesting to be able to say something like, you know, every 100 years, the whole board resets or something like that. Or not board, but whole circle of lanterns becomes unlit again or something like that. That would be, I think, very important to know. Okay? So that might be an intermediate goal of ours. And we find out, you know, every 100 years. So then 2018, you just need to pretend you started and we're just doing the first 18 years. And count that number up. So, does it become unlit ever? So, after year n squared is lit. Well, let's say n squared... after n squared is lit. Well, n squared modulo 101. I will at least write that. It will be unlit if there is some year m with m squared modulo 101. The remainder of m squared, if that's equal to the remainder of n squared modulo 101. And so now, I was just saying modulo as a short form for saying remainder, but now I think we're actually going to have to do some modular arithmetic. So that would mean that m squared is congruent to n squared mod 101. I guess that would be m squared minus n squared is congruent to 0 mod 101. Well, actually, I guess we could have just said that means that 101 must divide m squared minus n squared. You didn't have to write the modular arithmetic notation here. I know some people don't like modular arithmetic. It's useful, and it's, you know, it comes up a fair bit in university in certain places. So it's a good thing to know. Okay, so 101 divides m squared minus n squared, but this is a difference of squares. So, and 101 is a prime, just like 5 was. So this is m plus n times m minus n. Now I don't know which one 101 has to divide, but I know that either 101 divides m plus n or 101 divides m minus n. So either m plus n is 101 times some r, or m minus n is 101 times some r. Does this help me at all? Well, I suppose with this one, we get that every 101 years the lantern will change its sign, but doing something similar over here, it's not quite the same. It's a little odd, but so if I had 0, 1, 4 is good, 9 is good, 16, 25. I know these probably aren't the proper relative positions, but these are the numbers I'm considering, and then 81, and then I guess 100 would be up here right next to the 0. And then after 100, which would be year 10, we'd do 11, so we'd be over to 121. But subtract 101 from that, and that'll be 20. And then you'd get 144, and that'll fit in somewhere. 144 minus 101 will be 43. Okay. So, and then 169 would be 68 is one that's important. Okay. What would be next? 196 for 14 squared would be 95. Okay. And these numbers aren't... I'm not exactly happy with these numbers here. For a moment I thought, well, gee, 81 and 20, they add up to 101, but there doesn't seem to be sort of anything similar. 95 and 4 don't add up to 101. And 68 doesn't add up with any of these. It would be 36 if it was going to be anything, so... I guess and I don't want to have to do 101 squares of things. I don't know, let's try and continue on. So, well, we don't need to draw the circles. Let's just say 0 is important, then 1, then 4, 9, 16, 25, 36, 49, 43 was in there, 64, 68, 81, I know 95 was good, 101, or sorry, 100, so that's good. And then what would it be after that? 15 squared, so 225, so that would be over here at 23. And nothing good seems to be happening here. So I'm not exactly pleased with this, but okay. So every 101, every 101 years, it looks like things should repeat. Except there's this. So 101 minus n. So does that mean in year 100, because that would be r equals 1, n equals 1. In year 100, it'll unlight 1? Is that what's going to happen? And then in year 102, it'll light 1 again. So it looks like everything repeats after 101 years, but does everything also reset at that point? But, yeah, 100 is equal to minus 1 modulo 101, and that squared is 1. So, yeah, that should work out. Okay, now do I have to do any more pattern recognition, or... So let's say this. After 101 years... After year 101... 101 squared, which is equal to 0 modulo 101, is unlit. We claim that every lantern is also unlit. Okay. So suppose not. If lantern K is lit in year N, or let's say after they meet in year N. The language here is just so weird. Is lit after they meet in year N, then K is equal to N squared modulo 101. Or I guess I could say congruent to N squared mod 101. But then K will be visited again in year 101 minus N. And become unlit. Basically what this is meaning is 2 changes guaranteed if 1 is. So if K changes its state, I guarantee you at some later point it will change back. Now you might be saying, well, hold on, how do you know these aren't the same year? In which case, very well spotted. We have to be sure that it's not, that N isn't equal to 101 minus N. But of course 101 is an odd number, so that's guaranteed to never happen. Fantastic. So I guess the thing to say would be something like, and I feel like this could be cleaned up a little bit better. So maybe something like claim after each 100 years the lanterns are unlit. Indeed, for any year N less than or equal to 101, there's a different year M equal to 101 minus N. Notice M isn't equal to N since 101 is odd, where N squared is congruent to M squared. This is also less than or equal to 101. So if the state of lantern K congruent to N squared changes, it changes back after year M. Again, I'm not entirely sure that the wording is clear, but I would underscore the fact that every 101 years, the lanterns each undergo an even number of changes. Okay. So that's good. So 2018 is equal to 1818 plus 200, which is equal to 2020, actually. Could have just said that. So it's 1919 plus 99, which is equal to 19 times 101 plus 99. Okay. So that's 19 years of things being flicked on and off, on and off, on and off, an even number of times, so everything sort of cancels out here. Right? As long as we're sure that... Oh, no, hold on. Cycle... After year 101, 0 will become unlit again. But the next year they don't relight 0. They would relight 1. So, all the non-zero lanterns and it's going to be after each 100 years, which I think I predicted ever so slightly. I didn't mean to, I was just picking a large number, and it happened to be quite close to the 101. Now, for any n less than 101, we can do that. There's no lantern 101. It all goes up to 100. So every 100 years, the non-zero lanterns undergo an even number of changes. So then, I think after centuries, the non-zero lanterns are unlit. In year 2001, no, I don't want to say that either. So I've got a bit of... So we claim after each 100 years, the lanterns are unlit. The non-zero lanterns are unlit if they started... No, that's... Well, I'm not going to erase it all. We're just going to... Let's ignore this. I'm onto the right idea. I feel like I'm not expressing it well, and my numbers are ever so slightly off. So, okay, in years of the form 101R, the zero lantern changes state. Okay, I think we can agree on that. Alright, now the next thing we want to say so in year 102 the lanterns will be lit. After year 100 the only lantern that will be lit is the 0 lantern. In 101 it gets unlit again, and then in year 102 the 1 lantern gets lit again. So I think what I can say is after each 202 years, the lanterns will all be unlit. There we go. The lanterns. Okay. So, for lantern 0, it changes in year 0 and year 101. So, I gotta change this again. After every 201 years. Right? Okay. This should be fine. I think. So that's when it changes. For lantern K, not equal to 0, it changes an even number of times. Right? In year 202, it'll all start again, I think. So, how can we say this? Well, if in year n, K changes, then K is congruent to n squared mod 101. Okay, good. And so in year M equal to 202 minus n, then K will change again. So for K not equal to 0, notice that n squared will not be congruent to 0. So 101 doesn't divide n. So n is not equal to 101. So M is different than n. And K undergoes an even number of changes. Okay, so it is lit and unlit, lit and unlit. So, okay, everything undergoes an even number of changes after 201 years. After year 202, the 0th lantern is lit again, and the cycle repeats. So, 2018 is 201 times 10 plus 8. So I think 8 lanterns should be unchanged. So in year 2011, lantern 1 is lit again. Let's just double check this. So why would it would lantern 1 actually be lit in 2011, or have I fudged the numbers again? Well, 2011 is 1919 plus 92, and 92 squared is not congruent to 1. Darn it! I'm messing up the numbers, and I'm not entirely sure what is going wrong here. So in year 201, the zero lantern. No, the zero lantern's already been unlit. It's not the zero lantern that gets unlit in 201, and so we don't repeat. Darn it. Something's going. I'm not adding up properly, and this is what's annoying me. Okay. Maybe I go back and look at a smaller case again. 1, 2, 3, 4, 5. I think this is the longest a Manitoba 10 has ever taken me, actually. Maybe I'm getting the numbering wrong by starting at 0, but I'm happy with 0. So, alright, real quick. 0 in year 0. 1 in year 1. And it took till... Right, it won't be... Well, wait, no. In year 101, it should be the zero lantern that's undone. So by that reasoning, in year 5, the 0 should be undone, but I didn't think that happened the first time. Okay, skip 2, so year 2 we're in 4. In year 3 we're in 4, and so that gets unlit again. In year 4 we're at 16, which is... Oh, maybe I just didn't count it properly the first time. And then in year 5, this becomes unlit again. So that worked out. So maybe it is after 101. But then the next year is going to be year 6, and we'll light this one, and we didn't light 0 first. We're waiting till it's unlit and I light 0. That's when the cycle repeats. So that's 6. 7 will be over here. 8 will get rid of it. Then 9. We're at 81, which is just 1 mod 5. And then at 10, which would be 202, we light this again. So it is... Yeah, it is going to be 2 times 101 minus 1, which is 201. And then everything repeats. right, except... It's year 10. Year 10 is 0. Year 10 is 0. So 202 acts as the same as year 0. And 203 acts as the same as year 1. After year 202, 0 is lit again. So after each 201 years, the lanterns will all be unlit. After 9 years, the lanterns were all unlit. And then the process starts again. So in year 202, 0 happens. So I think my mistake is the way I'm counting. It's this pesky start at 0 stuff that they were doing. This is turning out, I think, to be the greatest problem in the question, is I can't seem to get my timelines to match up the right way so that I'm happy. But I think, alright, so 202 is the same as year 0. So what's the closest 202 to 2018? Well, unfortunately, that would be 2020. So, okay. In the year 2020, 0 is lit again. So in 1919, 0 is unlit. Sorry, not in 1919, in 2019. It's not that 0 was made unlit, but 0 is unlit. Now, so in 2019, all are unlit. Right? That's the problem. It's not that it repeats every 201. It's 201 plus 2R. Everything will be unlit. That's what we've got here. Right? Yes. Okay. This is... So if I do 9 times 201, 202 times 9, 18, 18 plus 201. Okay, yes, it is 2019. Everything's unlit. So if I go back to 218, just after year 218, 1 will be lit. The one that will be extinguished in year 2019 to make them all unlit. Okay. There we go. Which one is that specifically? I think 4? No, it'll have to be something that's congruent to... I think it'll be 100. Yeah, it'll be number 100, I think. No, it'll be 1. Because this is congruent to -1, because this is congruent to 0, because it's a multiple of 101. So it'll be 1. Specifically, it'll be 1. So not only will one lantern be lit, but it'll be exactly 1 lantern. So how would I go about phrasing that? So this is good, but the conclusion of it is off. The conclusion isn't that every 201 it repeats. It's every 202R plus 201, the lanterns are unlit. And from there, we worked backwards. And that's how we get it. And so the answer should be exactly 1 lantern is lit in 2018, and that is the lantern in the 1 position, clockwise from the first lantern being 0. Okay, so as I say, the biggest challenge for me, at least there, was getting the counting right. Counting around the circle, and you might have this problem with modular arithmetic. I didn't think I had such a problem, but evidently this question has showed me that maybe that's something I need to brush up on. But it didn't go exactly as I thought, because I thought with this lighting and unlighting was sort of like turning lamps on and off. And I feel like they had a question in binary about lamps going on and off a couple years ago. So I thought maybe whoever does their binary questions was back at it again. But no, that was a good question. I liked it. I really liked the theory at the start that, oh, it's squares, and then 101 is prime, so that helps us out. Which I don't think I actually wrote down 101 is prime, but that's probably an important thing. Well, let's go back and highlight that. So, since 101 is prime. This wouldn't work if it were something like 6. Okay. But then, yeah, this, the exactly which things change, and I realized that an even number changed each time, but that was really, really a pain to put into words properly. But there we go. Probably would have gotten a lot of marks, not all marks, obviously, but a lot of marks just for the reasoning here. But did not quite get the right conclusion. But once you get whatever conclusion you get, you're just going to jump to which lanterns are which. And you probably will be more confident or more rushed and won't hesitate as much as I did. But there we go, one lantern, and that finishes off question number 10, and that finishes off the whole Manitoba contest. So if you're interested in more Manitoba contests, you can look for, well, I've done a bunch of the past ones. Of course, 2019 will be the next year that I end up doing. And of course, I've got other grade 12 level contests like the Euclid that you can look at. So there's a lot. Feel free to poke around the channel, and I will see you guys in the next video for more math.